Good morning or good afternoon, depending on what period you're watching this video. This is Mr. Copperthite here with a video lesson for you on multiplication and division with fractions. I want to take some time to kind of review this concept. As I'm understanding, this is a area of concern in some cases from the past about just working with fractions and being comfortable working with fractions. So I'm hoping that today I can kind of show you some examples to make you feel a little better about your abilities to work with fractions and to not be scared of them. So we're going to start with the straight up multiplication and division of fractions. I'm going to show you 5 different examples. You can see all of them to the left if you want. I'm going to show you today how to go through these. Now, first off, I want to point out, obviously, the easy part is multiplying fractions. Multiplying fractions is actually really the easiest of the 4 operations that you need to do to fractions between addition, subtraction, and division. Even division is easy, and you'll see why in a second if you're not aware of it already. So all you really have to do to at least get a starting point when you multiply fractions is you just got to multiply your 2 numerators and get a product, and then you're going to multiply your 2 denominators and get a product. So the product of these 2 fractions is one of the forms is 16 over 27. Now, ultimately, your goal is to also look and make sure that you can't simplify them anymore. Now, of course, in this case, we can't, because you have 8 and 9, and obviously these fractions, this fraction simplified, this fraction simplified, but you also may want to look for common factors between the numerator pair and denominator pair between the other 2 fractions as well. If you can find them, you can actually simplify them before you even multiply and give yourself easier numbers to multiply. But in this case, with this fraction, 8 and 3 don't have any common factors, 2 and 9 don't have any common factors, and of course the fractions don't have any common factors themselves, so the simplest form of this fraction will be 16 over 27. And that's that. So this example, again, super easy. Just multiply top and bottom of the fraction, and there's your answer. Now, if you have a mixed number, on the other hand, you have a little bit more work to do. You can't necessarily just multiply 3 times 2 and then say it's 6, and then do 1/4 times 5/6 and say that that's your fractional component. It doesn't work like that. The way we have to do it first is we have to first change to improper fractions, okay? Change to improper fractions. And the reason why is because we want to treat these like one number as opposed to 2 numbers. Because if we do the 3 times 2 and get 6, and then do 1/4 times 5/6 and get that fraction there, that's not the same number. That's really 2 separate multiplication problems. So you have to treat these like the same number. So the way to do that, change it to improper fractions. So here's how we do it. Here's our whole number. We're going to multiply by the denominator and get a product. In this case, it's 12. And then we're going to take that value and we're going to add it to the numerator. So it's going to look kind of like this. So if I do 3 times 4, right, that's going to be 12. And then I'm going to take and add 1 to that. So since this is 12 plus 1, that means that this fraction is 13 over 4. Right? And also, one other thing I want to mention is the word improper fraction. The only real meaning it has is that your numerator is greater than your denominator. Okay, improper sometimes sounds like it's wrong. It's not wrong. Okay, in this case, you have to use improper fractions to get it done right. So we're going to change our other fraction as well. Put our multiplication symbol in there. 2 times 6 is 12, plus 5 is 17. So this fraction here is 17 over 6. Now, there's no common factors between 13 and 6 and 17 and 4 because 13 and 17 are both prime numbers. So we have to multiply those straight out. So 13 times 17, that's 209. 209 because it's 10 times 13, which is 130. And then 7 times 13, which is 69. And 209, sorry, okay. So 209 over, and then 4 times 6, excuse me, that's 24. Now, if I wanted to make this back into a mixed number, I would want to divide 209 by 24. And if I do that, I can do that sort of by hand over here, right? Sort of. I'm drawing with a mouse here, so excuse the erroneous drawing. So if I did 209 here, and then divided by, kind of cheating a little bit here, right? Divided by 24, right? I know I can get less than 9 out of that. I believe I'm going to get 8 out of that. So if I do 8, 8 times 24 is 6, 8 times 32, 192. So 192 here, and then I'm left with 17. So my answer here as a mixed number is 8 and 17 24ths, right? So that would be the answer with this one. Now, again, if you report it as a mixed number, improper fraction, pay attention to the directions, because if the directions just say to multiply or simplify, then improper fractions are actually still okay. Mixed numbers are still okay. But if the directions say change it to a mixed number, make sure you do that, okay? You just have to divide, okay? So that's that. And also notice that the remainder, the 17, what's left, that becomes our numerator of our fraction. And we just use the same divisor, right? So you can see that that works like that. All right, so a mixed number obviously is a little trickier to deal with, but, you know, it is what it is. Okay. Now, I have a very simple example here. I just want to kind of show you the principle behind it. Now, we all understand the concept of a whole number divided by a fraction. Now, one thing I want to mention is that if you take a whole amount and you split it into fractional amounts, the answer to the division problem really is how many of those pieces would you have, right? So if you took two wholes and you cut each of those wholes into half, how many pieces would you have? Well, here's two whole parallelograms, right? So if I just kind of cut these into half, like if I cut them into triangles like that, cut them into triangles like that, how many pieces do I have? I've got 1, 2, 3, 4, right? So that means that 2 divided by half equals 4. Now, another way to look at this is, there's another way I can also kind of do the same kind of thing with multiplication. Instead of doing 2 divided by half, I could just do 2 times 2, but I'm going to put this over 1 so you can kind of see what we're doing here, right? And then if I do that, by the way, that's a whole number, right? So I can kind of do this like that, 2 over 1 times 2 over 1. That's just 4 over 1, or just plain old everyday run-of-the-mill 4, right? So basically what we're showing you here is that when you divide by a fraction, you're really just multiplying by the reciprocal of that fraction, which is the flipped version of that fraction. So as some of the students were saying in class on Friday, we're going to kind of do a keep, change, flip. Okay. So we say we're going to keep the first fraction, or keep the first number. We're going to change the operation from division to multiplication, and we're going to flip the second fraction. So when we divide fractions, we're really not dividing fractions. We're actually multiplying by the reciprocal. So let me show you an example of that. So we've got 7/9 divided by 5/3. Of course, I have an improper fraction in here, so we understand that we're going to get something that's lower. We have a fraction that's greater than 1, totally okay. So I'm going to keep the first fraction, just like before. Keep the first fraction, 7/9. We're going to change the operation. Let me put the words up here too, right? Keep. And then we're going to change, and we're going to flip. So we keep the first fraction, we change the operation to multiplication, and we're going to flip the second fraction now, and we're going to go 3 over 5. So you see how here, we don't really divide fractions, we just change them into multiplication problems. Now in this fraction here, we have a unique situation. We actually have a numerator-denominator pair that has a common factor. We have 3 and we have 9. Now we can divide both of those numbers by 3. So I can do that first instead and make my life a little easier. So I can make this into a 3, and then if I divide 3 by 3, it's 1, right? So now instead of having to do 7 times 3 and 9 times 5, now I just got to do 7 times 1, which is 7, and then 3 times 5, which is 15. So the correct answer here is that the 7/9 divided by 5/3 is equal to 7/15. Okay? So again, we're just changing it from a division problem into a multiplication problem. Now, if I have a mixed number in the mix, then I've got to do the same thing like with the multiplication problem. I've got to turn this into an improper fraction first, and then I'm going to do the keep, change, flip. So 5 1/2, that's 5 times 2 plus 1, that equals 11 over 2. So I'm going to keep that same, it kind of looks like an emoticon, 11 over 2. And then I'll rewrite the problem just for now, 3/4, and I'm going to do the same exact thing. Now I'm going to go keep, change, flip. So we're going to keep the 11 over 2. We're going to change the multiplication, and we're going to switch it up to 4 over 3. All right? And I'm sorry I forgot to change the color back to that. It's okay. We'll cancel the blue this time. So here we got 11. 11 does not have any common factors. 11 is a prime number, so only other 11s would work, or multiples of 11. And then here we've got 4 and 2, so we're going to switch this into 2. It's not a very good looking 2. Let's try that again. That's better. Not best, but then we change that to a 1. So here again, we've just got to do just some multiplication straight across, and try to simplify ahead of time, because then we don't have to worry about simplifying a larger fraction, or seemingly larger fraction, with high numerator and denominator. So we just do 11 times 2, which is 22, and 1 times 3, which is just 3. And if I want to express this as a mixed number, I can get 7 3s out of 22. So I'm going to do 7, and then I'm left over with 1. And then I would just keep the same denominator, so 7 1/3. So there you go. There's your quick primer or reminder on tutorial on how to divide and multiply fractions. Don't be scared of it. You're going to see obviously that there's some word problems in the activities that you have today, but just remember that really we're doing division and we're doing multiplication with fractions. So kind of read into the context. And what also might help you is if you reread the problems, if you're not sure what operation or what order you need to do, just reread the problem and plug in whole numbers only and try to make sense of the problem that way. And then that will give you an idea of which number goes first, which number goes second. All right, so I hope this video helped you. I hope that the lesson goes well, and I hope that your homework is productive. Don't forget about Freckle. Don't forget about the work that you got passed out today, and also don't forget about your homework. All right, so have a wonderful day, and I'll see you tomorrow.